Hello everyone, we will be discussing equations of motion, the derivation of equations of motion using a graph. So the agenda for today is of equations of motion graphically. To derive the three equations of motion, which are a quick recap: V is equal to U plus AT, S is equal to UT plus half AT square, and V square minus U square is equal to 2AS. We need to take a situation, and the situation is, consider an object moving with an initial velocity u at t equal to 0. After a time t, the velocity of the object becomes v. Since the velocity is changing, so this is the situation of, it represents non-uniform motion or uniformly accelerated motion. To represent the same in a graph, we do it on a velocity time graph. So y-axis represents the velocity and x-axis is represented by time. Alright, now since the object has some velocity at t equal to 0, so at this point you mark it as u, and since the acceleration is uniform, so it's going to be a straight line. After a time t, which we will show on the x-axis, the velocity of the object is v. Now, since we have to work with the area under the graph also, so we must label it. Let the point of intersection of section of the two axes be O. This point as A. Here, the point of intersection with the y-axis B, C, and then from A we draw a line parallel to the x-axis and label it as D, and the point on x-axis as E. The information that we can derive from a velocity time graph is quite a lot, and that is the velocity time graph gives us the following information. First, you can find the acceleration from the slope of the graph. Then you can also find the displacement by finding the area under the graph. So we'll start with the equation derivation. So we have to derive 3 equations. The first one, it is also called the velocity time relation, and this we find by finding the slope of the graph. Now slope of any graph is equal to y2 minus y1 upon x2 minus x1, or you can in short write it as y upon x. In our graph, the situation that we have taken, this is the triangle ACD. In this triangle, the slope will be y, that is CD, and x, that is AD. Okay, so let's write it there. CD upon AD. The slope represents acceleration, as we have just done. Now, if you see the graph, let me go back to it once again. CD has no value. It doesn't really represent anything on the diagram. So we are going to write it in some known variables. What are the known variables? The known variables are initial and final velocity. So CD can be written as CE minus DE and AD as OE, because both are parallel to each other, so they represent the same physical quantity. So CE minus DE upon OE. CE is V, DE is U, OE is T. So you get the equation very easily. Therefore, A is equal to V minus U by T. When you cross multiply, what you will get is AT is equal to V minus U, or V is equal to U plus AT. So this is our first equation of motion. In the same way, for the second equation, also known as the position time relation, since it involves position, so which means we need to find the area under the graph now. So area under the graph is equal to area of, now just see what geometrical figure does it represent. Yes, this is the graph AC. So if you see the area under the graph means this whole portion. So this, if you observe, it is OACE. This is a trapezium, right? Trapezium need not be the one which you are familiar with even if one side is straight, that still is called a trapezium because it has only two parallel sides. So in this case, OA is parallel to CE and OE is the perpendicular distance between the two arms. So if we apply in the formula, area of trapezium OACE, this is equal to half sum of the parallel sides into height. The two parallel sides are OA plus CE and the height is OE. Area under the graph represents displacement S. So S is equal to 1 by 2. OA is U, CE is V, and OE is time. For the second equation, it does not have final velocity in its expression. So we are just going to replace V using the first equation. Using first equation, S becomes equal to half U plus AT into t. Open the bracket. It becomes half 2ut plus at square, which will be ut plus half at square. This 2 cancels with 2 for the first term only. Therefore, you arrive at the second equation, ut plus half at square. Now, deriving third equation is almost the same as second, but you have to replace t, not v. So, you'll get the third equation of motion. So, for the third equation, which is also the position velocity relation, we start with the same area under the graph, area of trapezium OACE, which is equal to half sum of the parallel sides OA plus CE into OE into the height. Area under the graph once again S. So S is equal to, see, I am repeating the same steps. It will be easy for you to memorize, T. Now in the third, we need to substitute for T. So we use first equation of motion. So let me just recall it for you. A is equal to V minus U by T. So T is equal to V minus U by A. So we are going to substitute here. So I'll just reshuffle the terms, write it instead of U plus V, you can even write it as V plus U and T as V minus U upon A. This, the numerator, is like A plus B into A minus B. So you can use the identity and write it as V square minus U square upon A. Cross multiply 2A S is equal to V square minus U square. So this is your third equation of motion. So it's very simple to derive the three equations using the graph. But we always have to start from the graph, and whenever you get a question in the exam to solve, then you must draw the graph. Without graph, if it's a 3-mark question, you will be losing 1 mark. Thank you everyone.